So in this video, we'll be using the equation y equals to e to the power x for the exponential graph. So firstly, if we sub in y equals to 0, for this equation, no matter what value you sub into x, the value of e to the power x will never be equal to 0. And so that's why graph y equals to 0 is the asymptote of this graph. Next thing we'll do is to sub in x equals to 0. So y equals to e to the power 0. Okay, so as you know, anything to the power 0 equals to 1. So if x is 0, y will be equals to 1. And if y is 0, yeah, you will never touch y is 0. So because of the equation, y equals to e to the power x, as x increases constantly, like 1, 2, 3, 4, y will increase faster and faster. So it will be a curve. So as x increases constantly, y will increase faster and faster. As you can see, because here y increases a lot more than x increases. So that's the graph of y equals to e to the power x. Okay. As for y equals to ln x, log ex, this equation can be manipulated into x equals to e to the power y, which is the exact opposite of y equals to e to the power x. So in this case, the asymptote would be x equals to 0, which is this line, so it will never touch this line. And if we sub in y equals to 0, then x will be equal to 1. So here, y0, x1. So it will intersect x at this point. Okay, so according to this equation, as y increases constantly, x will increase faster and faster. So like that. Because as you can see here, x increases a lot while y increases a little only. So that's how you know how the curve goes. So this will be the asymptote. Make sure that the graph doesn't curve upwards.
The graph of the function y equals to e to the power of x is the reflection of the graph of the function y equals to ln x in the line y equals to x. As you can re-express this here as x equals to ln y, and you can re-express y equals to ln x to x equals to ey. As you can see from this, the graphs are still the same, but it's just that the coordinates here are interchanged. Therefore, this will be just a reflection